ESODTV.org.
Okay, hopefully in this segment I can shed some light on electronics. A lot of websites have schematics and plans on how to build your own stuff, and plus, most people who are into computer mods that put up websites and instructions automatically assume you know the most basic of electronic skills. However, if you don't, I'll shed some light with this segment. The first thing I want to cover is Ohm's Law. Ohm's Law is a basis of how to calculate power, current, voltage, and resistance, among some other things. I'm not going to get too complicated right now. You can easily go to Google and type in Ohm's Law calculator, and it'll do all the math for you. However, you won't have an understanding of what exactly it is. Now, Ohm's Law is really easy to remember just by remembering this phrase. Ohm's Law's very important rule is it's easy as pie. Now, very important rule, VIR, each first letter of the words, VIR, voltage, is current times resistance. And current is voltage divided by resistance. And resistance is voltage divided by current. Now, easy as pie, P-I-E. Power is current times voltage. Now, current is power divided by voltage. And voltage is power divided by current. Easy as pie. Now, another thing it deals with is the resistor color code. The resistor color code is really easy to remember if you can just remember this. The color code has individual colors. I'll explain a little bit more later on this. It has individual colors. Each color represents a numerical value. Now, to remember the numerical values, remember this. Bad boys rape our young girls, but Violet goes willingly. I know you're probably laughing right now, but each one of those words, just like, very important rule, easy as pie, it represents numerical value for each word and color. So, bad boys rape our young girls, but Violet goes willingly, translates to black, brown, red, orange, yellow, green, blue, violet, gray, white. That's 0 through 9. So, with just those little quick tips, you can understand it. Now, behind me I have my electronics work desk, so we're going to turn around, and I'm going to give you a brief intro to parts, components, schematic symbols, everything you need to do to read a map, use an iron, and build your first schematic. So, let's get to it. I have some components in front of me, most commonly used in a lot of electronics nowadays. This board that everything's attached into is called a breadboard. Now, a breadboard is really great for prototyping, so you don't have to get down and solder and get all messy with that mumbo-jumbo. The breadboard has rows and columns. Now, all of these long strips right here are actually one. They're all connected. However, they're not connected this way. So what you can do is you can place your parts inside of these little slots and arrange them so you can jump wires and components around without actually having to building a circuit board. Breadboards can come in whole bunches of sizes and shapes and forms. They can get a little expensive from time to time, but they're great if you plan on doing a lot of prototyping. I've hooked up some common components into the breadboard, and I'm going to show you their functions. The first runner-up is a diode. A diode is a one-way gate for electricity. It'll allow it to flow one way, but not the other. Now, I can't exactly show you how a diode works because, you just gotta take my word for it. It's just a one-way gate. Diodes are most commonly used as a crude form of signal flow protection, mostly for like serial ports and whatnot, just in case you plug it in backwards or incorrectly, voltage can't flow the wrong way. It could also be used in turning an analog voltage signal into a digital voltage signal. Now, a diode has an anode and a cathode. The cathode is signified by a black stripe on the diode, which is considered the negative. Cathode is always negative, anode is always positive. So this side is the cathode, this side is the anode. Our next runner-up is a light-emitting diode. I'm pretty sure everyone's seen these things. They're in all forms of electronics nowadays. When you pass voltage across them, they just light up. And just like the name implies, light-emitting diode, you can only plug them in one way. If you plug them in backwards, they won't work. Now, LEDs don't like having too much voltage and current run across them, so you have an unhappy LED if it just starts to slowly dim or even explode. Now, the LED will actually have a beveled edge to signify the cathode. and it'll have a rounded edge to signify the anode. So even though you have no idea like which one's which, now you do, because LEDs will always have one beveled edge. This little guy right here is called a resistor. A resistor is measured in ohms. Now, a resistor slows the flow of electrons, meaning it turns higher voltage into lower voltage. Now, you'd have to calculate exactly using Ohm's law what resistor you would need to create, from one voltage level to another. Now, the LED is hooked up in series with an LED. Now, this is the before a resistor, and this is after a resistor. Now, to determine a resistor's a resistor's ohm value, there's a color code on top of it with 4 bands. Now, the first 3 bands are going to be from black to white, like I described earlier. And the last band is going to be either gold or silver. Gold meaning it's got a 5% tolerance or a 10% tolerance. The tolerance being how far off from the exact value. I'll go into resistor color codes a little bit later. This little blue guy right here is called a capacitor. Now, a capacitor temporarily holds a small amount of electricity. Its storage value is called a farad. A lot of capacitors are either in the picofarad or the nanofarad. This little guy is actually hooked up in parallel with an LED. Now, capacitors hold electricity for a short amount of time, so when I remove power, instead of it just abruptly stopping, it slowly dims. Capacitors are often used in timing circuits, voltage regulator circuits, filters, audio circuits, and I think that's about it. I think that's the most common. Right over here, this little LED right here, I actually have, it's a multicolor changing LED. So when you apply power to it, it goes through all its wonderful little colors. Until it pops, because I'm passing a lot of voltage across it. Okay, I also have some basic switches. We all know a basic push-button switch. You push the button, it turns on. But it's not always that simple. There's 2 types of push-button switch. Normally open and normally close. Normally open means you have to push the switch to close the circuit, meaning letting electricity flow through. Normally closed means when you push it, it breaks the circuit, turning it off. Here's also another kind of push-button switch, keyboard key. Then you have a simple toggle switch. Turns on, turns off. Now, this has 2 posts, meaning it's a single post, single throw. It has 2 positions, on and off. This is single post, double throw. It has 3 pins, commonly used in selector switches, so you can select from one of 2 positions. This is a single post, double throw, meaning it's 2 single post switches combined into one. So you hook these 2 up to a device, and then you hook these 2, so when you flip the switch, each one of these is individually passing voltage across it. This is just some of the very basic of basic stuff, electronic components, and there are a lot more, such as transistors and inductors, but we'll save that for another day. I'm going to give everyone a quick crash course in soldering. Soldering is one of the best ways of putting together a circuit board. If you know of a better way, please tell me. Here's my soldering iron. Standard 30-watt Radio Shack soldering iron. Put on a new tip, though. Yes, your iron will start to turn this disgusting brown color. Now I'm going to plug my iron in, and as it warms up, I'll explain to you soldering. Now, the wattage of an iron will denote how powerful it is. Now, the hotter the soldering iron, the more industrial you can get. Like a 15-watt soldering iron is really good for low-end stuff. 30 watts in general purpose. 100 watt, you're practically welding. Now, when it comes to wire itself, this is called 36 gauge wire. The gauge of a wire determines how thick it is. The bigger the number, the thinner the wire. These guys right here, these are 22 gauge copper wire. Now, there are 2 main kinds of wire. You have stranded, which is much more flexible, and solid, which is easier to work with. Now, the thicker the wire, the easier it is to work with, especially when solid, and the more current it can actually handle. Now, when it comes to solder itself, I just get whatever generic brand Radio Shack solder, and that's it. Now, there's something called flux. Flux is a type of a low acid that helps solder stick to other metals. If you're having a very hard time getting your solder to stick to things, try a little bit of flux. However, it's not necessary. The solder that I usually get from Radio Shack already has flux inside. It's called a rosin core solder. Our iron is finally hot enough, and the first thing you want to do when you get a first new tip is put a little bit of solder on it. This is called tinning the tip, making it nice and silver. Now, I've also got something called tip cleaner, which once your iron's hot, you dip in it and it gives it a nice shiny coat. Now, I like to just flick all the extra off, and I'm going to zoom into this motherboard right now, and I'm going to show you how to solder a wire onto a very small point. Okay, we're zoomed into our motherboard, and the first thing you want to do is something called tinning your wire. And basically what that means is, trying to get the solder into the shot, put a little bit of solder, fucking solder, there, my solder. Put a little bit of solder, wrong end of the wire, on the wire. There we go. Now, we've got a nice silver tinned coat of solder on the wire. Now what you do is you put your wire up to the pad you want to solder, put your iron on it, melt the solder, and then there you go. It's soldered on. Now, look at the size of that point. Most people say it's so hard to modify, circuits with very small contact points. I just did it in seconds. I mean, this goes for everything. I mean, I have some 36 gauge Kynar wire. I'm going to tin the tip off camera, of course, because it's just so much easier for me. And I'm going to see if I can go and get, let's see, where's there a point on this board? Is this on screen? Yeah, that's on screen. Here we go. Here's a tiny little point. Now, of course, if you notice me shaking, I don't have the best nerves. I don't have a very steady hand. And of course, I think I need a beer right about now. There you go. I just soldered it on. That's a quick crash course in soldering. It's not very difficult. Primary thing is be very careful of the soldering iron. It's hot. I've actually seen people do phallic gestures with their soldering iron, drop it, and then grab the hot end. Well, let's just say that person wouldn't be coming home to his girlfriend, Rosie Palm and her 5 friends anytime soon. The best thing about soldering is practice, 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 practice. Don't practice on something you enjoy. This is an old, crapped out motherboard that I have no objection with soldering onto and off of. So, if you really do want to practice soldering, this is the way to go. If you have to solder 2 wires together, pre-tin both wires. If you have to solder components together, pre-tin both components. There you go, quick crash course. I hope you develop your soldering skills and let us know how well you're progressing with electronics. Have fun and good luck.